So today I thought we'd take a look at this screaming photon target robot. Basically had done a YouTube video on just this lower leg section, which was using a spring clutch mechanism, which I'd first seen used in a 1956 toy Z-Man, and I wanted to adapt it to something more modern, so I was using it to control the walking legs when the motor would run in one direction, and when the motor would run in the other direction, then it would stop walking. I was going to use that plus an added function at the top of the, well, let's start with the toy and then we'll get into all that. So when I turn it on, it's always going to walk, but I haven't got a laser pointer, so I'm going to use this flashlight. This is a target, and anytime you would hit the target with a bright light, then the robot will scream and react. There he is walking. So you get the idea. Basically, you got a target robot that you can activate with a laser pointer or a flashlight or whatever you want, and it screams, moves the upper part of his body, and moves his arms when you've hit the target. So, screaming photon target robot. And like I say, initially I was going to have the two functions. When the target is hit with the light, the motor just changes its direction, which engages a spring clutch mechanism for the upper half, and also triggers the sound thing and changes the color of the eyes and all that. But initially it was also going to stop the walking. So when you'd hit it, it would stop walking, then it would just sit there and twist and shake. The problem I was having, this is the larger set of legs. Initially I was thinking it looked too stumpy, and I was thinking, well, I'll just make a new set of legs and make it taller looking. But let me pull this back. But these legs tend to bind up every now and then. They seem to run pretty smooth now, but by the time I would put the body, the weight of the body on, and the battery pack and everything on there, it was causing them to jam up every now and then and twist the heck out of that spring clutch mechanism, because my spring clutch is made from a flexible, probably a polyurethane type spring. It's the thing that you would put your key rings on, then snap it around your wrist, like if you're going swimming or boating or something. It was that spiral. In the original 1956 toy that I took the idea from, they were using a metal spring, steel spring, and so it can take a lot more torque. It doesn't suffer from problems that a soft plastic spring would suffer from. So I gave up on the taller legs because they were binding, and went back to the original shorter ones, which I'd shown in the original video of the device. And again, by the time I'd stack all the weight on, every now and then they were giving me trouble, so I finally said, heck with it. I'll not put the little plastic spring clutch mechanism on the walking. I'll just leave it walking, but I'll go ahead and use the spring clutch mechanism to activate the upper part. So I still got the results, just not both functions. And I'm moving you over here to the little standard slideshow. And so what you're looking at here, these are the black legs. Here's the motor. This part is covered on a video, which I'll link to down below, showing how all that works. This gray gearbox going up, well, it's not a gearbox, it's the slip clutch part is in here. It's what activates the top part. This is just a standard motor driver, an H-bridge. And actually it's a dual H-bridge, but I've done a video, I guess I'll put a link to that too. I've done a video in the past that shows you how to wire it, so you can use one side as the H-bridge as an inverter. That way what it allows you to do is anytime you just give it a negative signal, you can reverse the motor direction, and makes it real simple. This is just a simple optical photo sensor that you can buy for like $1.19 on eBay and other China sites and stuff. It's just a small board. It has a little photo sensor which I put on longer leads so I could place it up in the middle of the body. I wanted to be able to get to this trim pot, so right below the target there's this hole, so I can go straight in with a screwdriver, and that adjusts the sensitivity of that photo sensor. So from electronic standpoint, it's real straightforward. I'm running the whole thing on 6 volts. That's a 120-to-1 gearbox, the TT type, and same power that, well, I'll just bring the 6 volts through a switch, bring them down to the boards, so both boards are getting their power. Anytime light hits the sensor, its output, which is right here, goes low. Anytime it goes low, it's going to reverse the direction of the motor. Anytime it's high, the motor runs in the opposite direction. So that part's all real basic. What else do I want to show? I don't know if there's more pictures here. This is up on top of the head. This is a greeting card chip. Normally when you would get these, the speaker's right here. It's sitting on top of the speaker. You'll have to envision that. Normally there would be 3 button batteries right here, but once I've already programmed the scream sound into it, I remove the button batteries so that I can power it off my lower power supply. But and normally there'd be a microphone here, and you'd have a play switch and a record switch. You remove all that stuff that you no longer need once you've programmed the sound into it. The nice thing about these particular ones with the 3 button batteries is they'll run anywhere from 3 volts up to 6 volts and work fine. Also, they will go into play mode on power up. So all I have to do is make sure I've wired it up right so that it gets the correct power. It'll automatically scream. These are the dual color LEDs. All I have to bring up to this top thing, the brown is a common ground. It's always ground. And then there's the red and the yellow, which actually they're hooked to the bridge, to the motor driver, so they get high in one way or the other. It's the body sitting on top of the new slip clutch. I don't think I took many pictures in there. There's a big cam that rotates when it drives, and these are up on the top of the shoulder. The head sits on here, so that's what kicks the body back and forth. And there's an actual picture of the little things that I was using as the spring in the slip clutch design. I think most of this lower drive stuff was covered in the earlier video, but here you basically can see the spring, and it just sits on the 2 posts. This upper post is connected to the motor. This lower post was connected right here, and when you turn your shaft in one direction, it's going to make the spring want to grab and tighten on itself and tighten down on the shafts. And when it's in that direction, it would transfer power. But if you turn it the other way, it's going to make the spring want to open up and release and spin freely. And it does. It worked quite well until I stacked on too much weight on this for the plastic spring, and then basically it would start knotting up or slipping, not working reliably basically, which was a shame. This is the fitting that slips up under the slot. This comes down to here, showing the post fitting right into a piece of this. I mean, this system would still work. What I would have to do if I wanted to move a heavy robot and stay with this plastic spring is I would go with a faster gearbox, like the 48-to-1, that would move almost 3 times faster. Put my spring clutch there, and then instead of going directly into the leg walking mechanism, go to a gear reduction system at that point. That way the torque on this, the amount of power that this has to pass, would be less. This would be spinning faster, which would be in its favor for gripping and holding, and it would have less torque on it because we would reduce the gear ratio down at least 3-to-1 before driving the legs. So it is completely doable. I would just have to completely redesign the toy to work in a gearbox, and I didn't feel like redesigning it. I'd gotten far enough that I thought, what the heck. I think I've got the in case we go looking for that up on YouTube, I have it as a one-way spring clutch experiment based on the 1956 Z-Man the Brain patent. And so that was where I got the idea, and here's a 10-minute video, so I must cover all of that stuff in greater detail. I'd say go back and watch that if you're interested in it. And if I remember, I'll also link the motor driver mod that I told you about that I used in here. And I think that's about it. I think if we can pull back, we might want to leave with one more good scream. An old screaming Photon. In fact, we could just start off with a scream if I keep the light on there as soon as I power up. So you'd have your target, you'd try to hit your target. There you have it, the 3D printed screaming Photon Target Robot.